Hi, my name is Corey Gleason,
My name's Chuck again.
and now we are going to be doing the project demonstration for our senior project.
Upon initial power up, see the control station comes up with this menu. Displays the current day of the week and the time from the real-time clock chip, and displays the 4 menu options. We can select station, currently on station number 1, and then in parentheses it shows the IEEE short address designator. Select station number 2, and then select current data. So now you can see this data is from Saturday at 10:47.8. Temperature, relative humidity, and pressure, and gives you station number 2. Now we can select prior data, then it's going to ask us to enter the day of the week, hour, and minutes. Now we're going to enter 4/13/20. That will be the conditions at 13:20 Wednesday afternoon. This was when we did a test placing the sensor station inside a freezer. See, it's 6.3 degrees. The pressure was 1016 millibars and the humidity was 63%. So again, it has the date and the time. All of the prior data are going to be on times divisible by minutes divisible by 5 and 0 seconds. Now, set the clock uses the same entry format as the prior data. And it'll ask you to confirm. We want to change the time to Saturday at 10:16.
Next, I'll be talking about the sensor stations. Once again, we have the humidity sensor right here. It's the HM1500LF. We have an analog LM34 temperature sensor, and then the atmospheric pressure sensor, plus the real-time clock with its crystal. Now, the way this works is every 5 minutes we have this waking up from an alarm from this real-time clock chip. It will interrupt the PIC microcontroller while it's asleep. It will wake up and it will check these two analog sensors. If you notice, it is going into port A on the microcontroller, allowing it to receive the analog voltage. Both are 0 to 5 volts. Analog voltage will come in, be converted to digital through the integrated A to D converter in the PIC microcontroller. Once it gets converted, it's going to go through a 24-bit math routine and send it to Chuck, the control, or send it to the control station, where it'll be a hex to BCD conversion. Also, here's the pressure sensor. I don't know if you saw that light come on. That means it just woke up. It just did its 5-minute routine and put it in the EEPROM. But anyway, here's the pressure sensor. That is a digital. It works through SPI. That has a 64-bit math routine, I believe. Yeah, 64-bit math routine. And that goes straight, it logs in the data to the microcontroller through a 64-bit math routine through the SPI. The alarm, once again, you just saw that light come on. That it was a 5-minute alarm. The control station, every time it interrupts, it's going to set my clock so that we're always synced up. The clock should never be off by too far. Here's the wireless module right here. That's what's communicating with the control station's wireless module. Yeah, that's about it for this. Here's sensor station number 2, I guess.
You can see it's the hardware is identical. The software is identical with the exception of the address byte is one different. That is, station 1 was 0616. This is 0617.
And that is the only difference between the two stations. So we have, as you can see, we have a network of 3 devices, and as Chuck mentioned before, we only have 2 slave stations right now, but we can have up to 200 and
It's 240 because the first byte can't be 00.
right, so 240 stations. So it's a great network, and it was a great time working on this project.